Good morning, everybody. Hello.
Morning.
All right, good. Can you hear me well? Can see the screen?
Yes, sir.
Okay. All right. So we're online today, and decided not to do anything new, as I told in class, but let's use this session as a revision. But it is I am bringing our December revision a little bit forward to now, a part of it. And so we'll teach a new topic a little bit deeper in December, where we normally have a revision. All right, so I sent you this paper this morning. This is the January 2023 paper. I also sent you a revision document. I wanted you to try the questions first, and then I will work them out on the board. Well, on the screen now. So if it is that you did not do the questions, I still want you to go and do the questions after I do them. All right, because that's all a part of the process of practicing. We're trying to cement the information, cement all that we have learned, and retain it. Right? That's what I mean by cementing. We want to retain it. All right. I see a lot of persons not here. Actually, I have more persons in the physical class than we have online right now. So fortunately, the session is being recorded. So persons having problem, logging on, then they can go and watch the video afterwards. Anyway, and even persons in this session, I still want you to watch the video over again, to solidify anything that maybe you're not so clear on. I feel like you want to understand it a little bit better, you can go and watch the video again. All right, so I did specify the questions I wanted you to do on this paper, and I'm just going to work them out on the screen, explain them, and then it's for you to go and remember. When we get to March, it's going to be you working all the questions. Right? I'm doing them now for you as examples of how the questions can be solved, and then you are to go and do them again. But when we get to March, we're going to go into exam preparation phase of the program. The rules will be reversed, where you will write the questions first, and then I will do them after you. All right? That's how we're preparing for the exam. All right, so let's jump on to question one. Now, question one is something that I usually don't teach, like as a topic in class. Right? The question ones, well, we cover those mainly like by doing examples. Right? There are certain things that I might highlight and tell you that you must know this and that. But generally speaking, I do the question one topics, the section, the question one by example. So we can always do them when we're practicing like this. So this question is saying, by rounding each of the expression, each number in the expression below to one significant figure, we are to estimate the value of this. And this is a true way that we can use to estimate expressions sometimes. Hold on a second. Somebody's choosing to send me messages now. Okay. All right, sorry about that. Right. That's a true way we can estimate an expression like this by rounding off the numbers there to one decimal place, one significant figure, what have you. So what I want us to do is round this off to one significant figure, round this off to one significant figure, round this off to one significant figure, and therefore estimate what overall that is equal to. So if we carry out that process, then this will be equal to the square root. We're rounding 108 off to one significant figure. Remember, when you have a number, the first significant figure is the first non-zero value from left to right on the number. So the first significant figure in the 108 here is the 1. Also remember the size of the number cannot change. So this number is in the hundreds. It's 100. And so the resulting number must also be in the hundreds. If the correct number in the thousands, the resulting number must be in the thousands. If you correct a number in the 10,000s, the resulting number must be in the 10,000. If you correct a decimal in the hundredths place, the answer must still be in the hundredth place. The size of the number you're correcting must not change. All right. So when you correct this, the first decimal place, let's look at it this way: 108. I want to correct that to one decimal place. That's the first decimal place right here. So what you would normally do is look at the value that comes after it. And if this value is 5 or more, then you would use it to increase this one. But since this is a 0, it's not going to change this. And so it stays 1. And then all the values after that become 0 to the extent that the size of the number stays the same. So it then becomes 100. When we correct it to one significant figure. All right? That's 108 under the square root sign divided by, again, we're going to correct this to one decimal, one significant figure, 19.72. So correcting this, so we're going to use the 9 to correct, this is the first decimal place. We're going to use the 9 to correct that one. So because the 9 here is greater than 5 actually, it's going to increase this 1 and make it into a 2. And then all the values after it become 0. And so it will become 20. If you want to put 20.00, no problem. That's more correct. This to one significant figure. Mute the mic, please. Somebody's mic is open. And then this number, I want to correct to one significant figure again, 5.296. So we're going to add that number. All right. And so we're correcting this value using this 2. This 2 is a value less than 1. So this 5 remains 5. And then all of the digits after it becomes 0. So it becomes 5.000. All right. So what you realize is that the square root of 100 is actually 10. And under here, we will have 20 plus 5. Mute your mic, please. Mute your mic if you're not speaking relating to the class. Mute your mic, please. Oh, Lord. All right. So this 20 and this 5 becomes 25. And so really solving 10 divided by 25. And then that can be simplified further. So we can divide this by 5 and get 2. Divide this by 5 and get 5. So that is the answer. Right? That's the estimated value. If you want to write this as a decimal, it will be 0.4. So it is either this or this. All right, that's an estimate of what this is, 0.4. Maybe what you can do is calculate this out normally, and it must be a value close to 0.4. Might be more than 0.4, or a little bit less than 0.4, but it must be a value close to 0.4. In fact, we can actually get the calculator and work it out. Let's do it and see what it works out. Because sometimes the question will ask you to work it out with a calculator to a certain number of decimal places. All right, so let's see. Let's see what that should be. I'm looking for my calculator. Yeah, here it is. Let's see what we get if we work it out with a calculator. I want the answer to be something close to 0.4. Let's see. So I'm going to set it up as it is, and that's why I want to get one of those textbook display calculators where you can type in the values exactly as it appears on the screen. That's 19.72, or exactly as it appears on the book, on the exam paper, 5.296. See that? It actually works out. If you look at it, it actually works out to 0.415 and so on. That's what it works out to. So if you correct this to one decimal place, it's going to be this answer, 0.4. And so this is a good answer for us to get. All right? This is what we're getting on the calculator. And if I do this in the exam and I have my calculator, and I wrote this out and I get 0.4. I'm going to do that same calculation that I have here, my calculator, and see if I'm getting this. See if it comes out to a value close to that, which is 0.415. And so I'll be able to accept this as an answer. All right, so you don't just run away when you can check it. Once you can check it, you check it because you want those marks. Next part wants us to find the next part wants us to find the exact value of this thing, and we have to give our answer as a mixed number in the simplest form. A mixed number. So what's a mixed number? A mixed number, for example, is this one, comprising of a whole number and a proper number. That's what a mixed number is. A proper fraction, a mixed number and a proper fraction. All right. So normally they would tell you to use a calculator to work this out. Normally. All right. But because they did not say that this time, what I would do is go and work it out step by step. So following the P-board math system, we have to work out what is in the bracket here first. All right. So first I'm going to turn this into an improper fraction by multiplying the 8 times 3, which is 24, and 24 plus 3 is 27. So this is an improper. The improper fraction becomes 27 over 8. All right, because it's 3 times the 8 plus this 3. All right, and that is being divided by, let's write this 7 better. 27 divided by, then I have to work out what is in the bracket. Now, these are two fractions I'm adding. When I'm adding fractions, I want them to be related, meaning I want the two denominators to be the same. So I'm going to adjust this one so that it has the same denominator as that one. And so I'm going to have 5 over 12 plus this 1/3. I'm simply going to multiply. Let me show you. I'm going to multiply on the here by 4. I multiply the numerator also by 4 so that the denominator becomes 12 like this one. And so it's going to become 4 over 12. Now that I have the same denominator, I can go ahead and add the numerator here. So it becomes 27 over 8 divided by, this becomes 9 over 12. 9 over 12. And when you divide by a fraction, you invert and multiply. I can also reduce this 9 over 12 now and write it as 3 over 4. Because I can divide this by 3 and divide this by 3. All right, so I can recognize this as being 27 over 8 divided by 3 over 4. But this then becomes equal to 27 over 8 times 4 over 3, because I multiply, invert, and multiply. So you multiply by the inverse of that reciprocal. All right, and then we can start to cancel values. So what it is, we are doing 3 into this 1 time, 3 into this goes 9, then 4 into this 1 time, and 4 into this goes 2. So it becomes 9 over 2. 9 over 2. 9 times 1 is 9. 2 times 1 is 2. And then this 9 over 2, the one has a mixed number. You have to divide the 9 by 2, you get 4, remainder 1 over 2. And that is the answer as a mixed number, 4.5. 9 over 2 is 4.5. But good at that? But okay?
Yes, sir. Yes, sir.
Yes, sir.
Then if you have your calculator, you can always just check this again in the calculator to make sure that your answer is correct. Right? By typing that exact thing in the calculator. Just to make sure, because you have a calculator inside here with you, why not use it to make sure you want to get these answers correct? So I will do this mixed number, 3 and 3/8 divided by a fraction. And then we are going to put in that 5 over 12. You need to get one of those calculators, guys. We can see what you type exactly as it is, or you want it to be. Textbook display calculators. See, we get 4.5, 4.5, and your calculator can show it also as the mixed number. Here it is as a mixed number right here. So it's right here, 4.5, right, which is what we have out here. This 4.5. All right, so you know your answer is correct. Sometimes you want to just make sure when you can, just do that quick check. So you do the work on the paper, because the question did not say use a calculator. If it said use a calculator, then I would just type this in the calculator as it is and just write down the answer. Right? In addition to that, they're giving you 3 marks, so it means therefore that they want me to show some work. All right, so I will do that this time. All right, let's continue. This question says some simple percentages, right? It says, due to COVID-19 pandemic, the number of available seats in a hall was reduced from 120 to 93. From 120 to 93 was reduced. Calculate the percentage this decrease in the numbers of available seats. So the percentage decrease really is the decrease divided by the original amount. Let's just write original right here, origin. Let's write orange for original. Multiply by 100. That's why you calculate the percentage decrease. The decrease divided by what you had before when you started. You always divided by the original. It's a percentage of the original amount. So what is the decrease? The decrease is 125 minus 93. This is 125 minus 93 divided by the original amount. It's a percentage of the original amount, which is 125 multiplied by 100. That's what you're calculating. Now, 125 minus 93 is 32. So that's 32 divided by 125 multiplied by 100. We can drop that in the calculator quick and get it. In fact, you could put it in the calculator from right here and put the answer rather than this additional line. All right. You can use the full power of the calculator. So it's a fraction, 125 minus 93 divided by 125, and you multiply that by 100, and it is 25.6, 25.6 reduction, 25.6% reduction. And let's check if we had the right 32 there. We'll put 32 here, same answer, 25.6, and that's it. But okay with that? But okay?
Yes, sir.
All right. This next question is just some transposition, really. It says, Mika invests a certain amount of money in the bank that pays compound interest at a rate of 2.5% right here, 2.5% per annum per year. At the end of 2 years, so 2 years is the time, the value of her investment is this. So this is the amount that she has accumulated. Question says, what is the amount of Mika, what is the calculated amount Mika invested? So what the amount invested is called the principal amount. So they give us this formula for compound interest, and they're defining what each thing means. All right. So it's a matter of basically placing the values that we have in the formula and transposing to find what they want us to find, the information that we know. The information that they want is the amount that she invested, which is the principal. See here, the principal. Principal is the original amount, the original value. So we're trying to find the P. All right. So that's what we need to recognize. Then what is the A? The A is a total amount after n years, which is this figure. So this is the A. This figure right here is the A. All right, in that formula. And then now there is the rate per annum, and the rate per annum is given right here. So this right here is your R. This right here is your R. Let me leave the P there. So this right here is your R. I'm going to put a capital R, even though I have a common R here. All right. So we said this is the amount you invested, the P. And then the T, the N, the number of years, the N. Sometimes they use T for number of years, time. But N is a number of years, right? So this right here will be an N. This right here, the number of years with the N. So if we use this formula and plug the values that we know in it, then we are gonna get that the accumulated amount, which is this. Let's write it out. 7564.50. I don't have to put the dollar sign. When I'm finished, I put the dollar sign. is equal to the principal amount. I mistake, pressed the wrong thing. Right. Is equal to the principal amount in front here. I'm going to put the P for the principal amount that we're trying to find into 1 plus the rate is 2.5. The percentage is already taken care of by the 100 being under here. So the R is just 2.5 divided by 100. And you're raising that to the power n, where the n is equal to 2. So n is equal to 2 because 2 years. So it's 2. That's what you're solving, and then trying to find the P from this. Trying to find the P from that. So essentially what you can do, you can take this and just divide it under this side and get the P. So the P, if I were to do that, if I were to take this and divide it under here, I'm going to show you the power of the calculator now. Then the P would be equal to 7564.50 divided by 1 plus 2.5 divided by 100 squared. So what it is, I don't have to work out these parts first, step by step. I don't have to do that and work out those little pieces. I can do one calculation with my calculator here, and then I can write my answer for what P is by working that out and put the dollar sign on it. So let me show you now. I'm just going to put all of this in the calculator one time, and that is what I want my students to practice. You don't have to use a calculator and working out every little thing, like working this out, and working this out, and you have to work out the square before you divide it. No, notice I don't give a lot of space to do that much work. You can just write what the expression would be in terms of P, and then all you have to do is enter this correctly in the calculator. That is why you need to get one of those calculators, guys. You're using the full capacity of the calculator. All right, use the full capacity of the calculator. So get a calculator that can do all of this work. So it's a fraction. On the numerator, I have 7564.50. I don't have to put the 0, but I'm putting it still, and just check that we'll put on the right value there. 7564.50. And we're dividing that by a bracket. Put in an open bracket. We're going to put 1 plus the fraction 2.5 over 100, close the bracket, then raise it to square it, raise it to the power 2. See that? I'll get 7,200. Type it exactly as it is that you want it to be in the calculator and get your answer straight. 7,200. So the answer here is 7,200. That is my answer. So don't need to work out this part, then work out what that is, then square that, and then divide. No need to do that. One calculation. Oftentimes, you really only need to use your calculator once to get an answer when doing these questions. But to get that, that's what I want us to practice. That's what I want. It's only 2 marks for the question, and so you're not going to get a lot of marks for the small working out of this and that and the square. No, you're not getting a lot of marks for that. Just do this, right? Maybe what it is there's going to be 1 mark for setting this out the right way, recognizing the correct values, and 1 mark for eventually ending up with the right answer for the 2 marks. All right, so working out this part of it by itself, not going to really gain you any mark. Believe me. All right, so that is the end of number 1, guys. What good? What okay with that?
Yes, sir.
All right. I'm going to jump over and say we're going to do number 2 as well. Number 2 as well, right? So I want us to simplify these expressions. All right, so this is an indices question. When you raise a power to a higher power, you can multiply the powers. So this barely becomes equal to x to the 3 times 2, which is x to the 6th power. Another way to look at it, you can say, or, let's look at it another way, or this, the square here means you're multiplying it by itself. Mute the mic, please. X cubed times x cubed. That's what this means. And then when you multiply numbers with the same base, and the base is x, you can add the powers. So it will become x to the 3 plus 3, which is still giving us x to the 6th power. So when you want to do it like this, recognizing that when you raise a number or raise a power to a higher power, you can multiply the powers as I did here. Or you can recognize that this is x cubed multiplied by x cubed, and then you add the powers. When you multiply numbers indices with the same base, you add the powers. All right. So for this one now, this divide, I'm dividing. And again, it's indices. When you divide, you subtract the powers. You have to be careful now because that's a negative power. So this one will become equal to, let's look at it, y to the 8 minus a negative 5. But understand that the minus here means that we're going to subtract the powers, and we are subtracting this power, which is a negative 5. So it's a minus we have. But I go to that, this minus becomes a plus. So it becomes y to the 13 power. That's the answer, y to the 13 power. But I go to that, but okay?
Yes, sir.
Remember,
Yes, sir.
when you divide
sir.
indices, right? When you divide indices, you subtract the powers. So it is this power minus this power, because you are dividing, right? I'm subtracting the powers. So it's 8 minus negative 5. If you want it, you could put this in a bracket like that. Same difference. Don't make a difference. All right? So that is that. All right, next one. Next one wants us to factorize this. Look at it. There's just a common factor of the y. So we're going to factor the y out of it. And we'll factor the y out of here. We get an x. Factor the y out of here. We get a negative y. And that's it. This cannot be factorized any further. And then now they want us to factorize this one. Clearly that's the difference of two squares. You must recognize that. So it becomes x minus y times x plus y. Difference of two squares. You have to recognize these things. X squared minus y squared is the difference of two squares. It becomes the difference of the values multiplied by the sum of the values. All right, values being x and y in this case. Then it says hence. Hence means we have to use these results, right? So the part one, and they ask us these two things. And part two now is saying hence. Simplify this. In other words, we have to use these results down here. All right, that's what the hence means. Now, if you look at it, this numerator is what this was, and we know it's equal to this. So we want to write what it is out here. It is y into x minus y over, and this denominator is what this is, and this gave us that difference of two squares. So when I write it again on here, x minus y times x plus y. And so these two cancel each other because it's x minus y over x minus y. Yeah? So this x minus y cancels this x minus y. And so we are left with y over x plus y as the final answer. So this becomes y over x plus y. That is the result. Y over x plus y. But good? But okay?
Yes, sir. Yes, sir.
All right. Simple stuff. All one mark questions. Let's look at this one now. All right. So this one looks like a little bit of sugar on it. Eh? Quadratic. All right. This question says the diagram below shows two rectangles M and N. So this is rectangle M. That's rectangle N. It says where dimensions are expressed in terms of x. So this dimension is x minus 3 centimeters. This one is 3x plus 4 centimeters than M. And this one is x minus 3 centimeters, same as this, x minus 3. And this one, though, is x plus 2. Question said, Given that, so they're giving us some information now, something that is factual. Given that the difference between the two areas, difference between the areas of the two rectangles is 64. The difference between the areas of two rectangles is 64. We have to show that this is equal to that. So all we have to do now, guys, is get an expression for the area of this one and minus the area of this one. Put it equal 64. As I said, the difference is 64, and when we simplify it, we must get this. That is all. All right. So what this is saying is that the area of M minus the area of N is equal to 64. That's what this statement is saying. The difference between the areas is 64. So what is the area of M? The area of M is this times this. Let's write it out. So it is x minus 3 times 3x plus 4. That's the area of M. Minus the area of N now is this times this. And I'm deliberately writing the x minus 3 first, as I did here. All right? So it's x minus 3 times x plus 2. That area minus this area is equal to 64. So we have this equation now. Basically, when we simplify it, it's supposed to give us that. All right? So it's a matter of how do we simplify this. Now, I can simplify it by expanding this out and expanding that out and then transposing the 64, because it's not have 0 on the right side. I can do all of that. But then I can also do a way where I recognize x minus 3 as a common factor of these two expressions. And if I factorize the x minus 3 out of two of them, then I can say out of this one, I'm left with 3x plus 4 minus, and out of this one, I'm left with x plus 2. I'm subtracting all of x plus 2. So I make sure I put it in bracket. And that is all equal to 64. All right? Then now I can consolidate what is inside here. Consolidate it. I'm going to write by the x minus 3. If you look at it, it becomes 3x minus this x. If I were to expand out this bracket, I can read it as 3x minus x. That is my 2x. So I'm getting 2x. And 4 minus 2. 4 minus 2 is 2. So I'm getting plus 2. Then I can transpose this 64 over this side and have it as minus 64 equals 0. Then here I can factorize 2 out of this as well. I can expand this now. But in addition to that, I can factorize a 2 out of this. Either way, the result is going to be the same. All right? So let's say I factorize 2 out of here. I know, let me just expand this. I'm going to do this times this and this times this. So I'm going to get 2x squared plus 2x. That's this times this is 2x squared. And this times this is 2x. I'm going to minus 3 times that 2x, give me minus 6x. And minus 3 times 2, give me minus 6. I'm subtracting again that 64 equals 0. Then if I put the like terms together, I think I'm doing too much work, but it's okay. This is the only squared term, so I'm getting 2x squared. This and this give me negative 4x. Negative 4, so I'm getting minus 4x. Then this and this giving me negative 70. So I get minus 70 equals 0. And I realize that each of these can be divided by 2. So I'm going to divide by 2. When I divide this by 2, I'm getting x squared. Divide this by 2, I'm getting minus 2x. Divide this by 2, I'm getting negative 35. Divide this by 2, it remains 0. And so I've shown it. This and this is the same thing. Same thing. So therefore shown. I've shown it. 4 marks for doing that. Nice question. Nice question. I don't want us to solve anything, just to show that. Everybody good at that? Could have done
No,
another
sir,
way by
Yes, please.
could have done another way by expanding that and expanding that. Could have done that way as well. But we have to be careful with this negative sign inside here. But okay?
Yes, sir.
Everybody okay?
Yes, sir.
Sir, could you read it?
We do it again. Do it,
Yes, sir.
do it the other way. Do it the other way or do it
Yes,
the
sir.
same way again.
Same way, sir.
Same way. All right. All right. From the beginning or from here?
From the beginning.
All right, from the beginning. All right. So the question is, do you understand this information right here? That says they're telling us that the difference between the two areas is 64 centimeters squared. Understand that?
Yes, sir.
So that's the information we have to use to show this. So the mathematics working on, that's why I have to practice and see how questions are structured. We basically have to set up this information that I have underlined, that they have told us, set up that information. And if we set up that information and simplify it, we are going to end up with this. That's how the mathematics work. So we need to get an expression for this area and an expression for this area, subtract them and put that difference to be equal to 64. That's what I wrote here. That's what this statement here means that I wrote first. AM minus AN equals 64. A means area. I'm saying the area of M, that is the area of this one, minus, because they said difference. The area of this one is 64. When I look at it, it's obvious to me that this one is a larger one. This one is a smaller one. All right? So I'm using the larger area minus the smaller area. And I know that this one is larger. Remember, I know this side and this side is the same. And it's obvious that this is larger than that. That's a 3x plus 4 versus an x plus 2. So this must be the larger one. So the larger area minus the smaller area is equal to 64. So what is the larger area? The AM. It is the product of these two things, length times width, or width times length. So I'm going to write that. They gave it to me as the algebraic expression, no problem. Write the area as a product of those two sides. So that's right in the area of M. So that's x minus 3 times the 3x plus 4. This represents the area of this one. Then I'm subtracting now the area of this one. And the area of this one now is this length times this length. So I'm going to put it as x minus 3 times x plus 2. That's the difference of the two areas. They tell us it is equal to 64. That's what they told us. So I've established a relationship that basically is complying, or that is aligned with what they have said here. That's what we have produced here. And so we are at a stage now that when we simplify this that they have told us, we are supposed to end up with that equation. That's how these things work. All right, that's how the questions are structured. They give us some information, and you're using that information to prove what they wanted to get. So it's now a matter of how do we simplify this and simplify it down to this. That's what the question is now. That's how do we approach it? There are multiple ways we can approach it. I can approach it by recognizing that I have a common factor of x minus 3 in those two terms, and therefore factorize x minus 3. Or I can expand out this, expand out that. In fact, what I'm going to do it this way this time. I'm going to expand this and expand that. I think it's a longer way, but still I'm going to do it. Because I did the first one in the video, and you can go and watch the video of how I did the first one when I factorized. But just to do it another way for you. So I'm going to expand it. I'm going to expand out each of them and subtract. All right? So when I expand this, it is this term times this term. Let's do it the short way. First term times first term is 3x squared. Then the last term, we're going to get 3 terms from this. The last term is the second term times the second term. That's negative 12. Then the term in the middle is the sum of the far product and the near product. You have to remember these things. The far product and the near product gives us the term in the middle. So right here, you know, the far product is the x times 4, which is 4x. And the near product is negative 3 times 3x is negative 9x. Negative 9x and 4x is negative 5x. So my middle term is negative 5x. I'm going to write the negative 5x in here now for my middle term. Minus 5x. So that's what I'm getting when I expand this first bracket. Subtract. And because I'm going to subtract what this works out to be, I'm going to put it all in a bracket. You can put a big bracket like this for one. And expand this now. All right? Because I'm subtracting, I have to be careful with those negative signs. So I'm going to do it the same way. X times x is x squared. The last value is going to be negative 3 times 2 is negative 6. The term in the middle is the sum of the far product and the near product. The far product and the near product. The far product is x times 2 is 2x. And the near product is negative 3 times x is negative 3x. Negative 3x and 2x is negative 1x, or there's negative x. So the middle term is negative x, negative 1x, or negative x. That's right, negative x. So it's minus x. And all of this is equal to 64. All right? I'm going to proceed to work out now what all of this is equal to. I'm going to be careful with this negative sign. So it's basically all of this thing minus what is in the bracket there. Careful with the negative sign. So watch this now. I'm going to do 3x squared minus x squared. It's going to give me 2x squared. So I'm going to get 2x squared. Then I'm going to get minus 5x minus a negative x. In fact, you know what? Let me expand out the bracket with the negative. It might be clearer to you for that. So I'm going to write back this first as it is. And put by the 3x squared minus 5x minus 12. I'm going to expand this negative over this bracket. So I'm going to get minus x squared minus x squared. Then this minus give me a plus x. Minus plus, I'm getting a plus x. And then this minus 6, give me a plus 6. And this is all equal to 64. 64. All right. Then I'm consolidating the values now. So the like terms are put them together. So this is 3x squared minus x squared. 3 minus 1 is 2. So that's 2x squared. Then the x values now, that's minus 5x plus x. That's negative 4x. That's negative 4x. Then the numbers now. Negative 12 plus 6 is negative 6. That's negative 6. And this is equal to 64. But if you notice I have 0 on the right side, I'm taking more steps than I need to. So I'm going to transpose this 64 here now. I'm going to get 2x squared minus 4x. When I carry over the 64, it becomes negative 64. Negative 64 and negative 6 give me negative 70 equals 0. Then I realize I can divide each of these terms by 2. So I'm going to do that. Divide each value by 2. Divide this by 2, it becomes x squared. Divide this by 2, it becomes negative 2x. Divide this by 2, it becomes negative 35. And divide 0 by 2, it remains 0. And so I've shown it again. Better? Better this time? Hello?
Yes, sir.
Yes, sir.
All right, cool. All right, so let's go on to the next question. That finishes number 2. Number 3 is a transformation. We haven't done that topic as yet. And this is transformation still. We're going to do this topic soon after matrices. Then we come to coordinate geometry when they give us a graph. I like it when they give us a graph because you can literally see what you're doing, and what you calculate must be consistent with what is on your diagram. This question says the lines M and M are drawn on a square grid, right? It's basically on a graph. So this is the line L, that's a line M. Right off the bat, I know that this line has a negative gradient, but sloping down from left to right. I can actually see what the gradient is. This line has a positive gradient from left to right, but sloping upwards. All right. You can see that this y-axis intercept is -2. This y-axis intercept is 3. I can see the gradient of this line by, for example, using these 2 points. These are reading, so we can see it more clearly. I can use between these 2 points, rise and run. So I would have to come down 1. I remember going from left to right. Rise -1, run 2. So I know right away the gradient of this line is -1/2. Then on this line, I can use these 2 points, for example. Going from left to right, I would have to rise 2, and run 1. So for this line, the gradient is 2/1, which is 2. So already I can know the equation of each line by just looking at the graph, because I can see the gradient, I can see the y-axis intercept. So I can literally write them here. For line L, the equation is y equals, remember, it's y equals mx plus c. Is the equation of a line where you know the m and the c. So for line L, the gradient is 1/2, so -1/2 means -1/2 x, and the y-axis intercept is 3. And for line M, it will be y equals, the gradient is 2, and the y-axis intercept is -2. So I already know everything about these lines before I even start answering the question, just by observation. Simple things like that. Right? And the 2 lines intersect each other at the point 2, 2, right here. That's the point 2, 2. They intersect each other at the point 2, 2. So we are just gonna answer the questions now as mere formality, because we know everything already. Because everything is there on the graph, and these are the things that they'll be interested in: the y-axis intercept, the gradient, the equations, right? And the point of intersection. They might also need a relationship between the lines, the geometric relationship between them, whether they are parallel or perpendicular. These are perpendicular because if I multiply the gradient, the -1/2 and the 2, they equal -1. When the product of the gradients equal -1, the lines are perpendicular. So I have not done anything yet, but I know everything already. So answering the questions now is just a mere formality. When they give you these lines on the graphs, everything becomes super easy because everything is in front of you. All right, so let's just answer the questions now, though. First thing they want is the x-axis intercept of L. Where does L cross the x-axis? That's what it is. And it says coordinates. So I have to give both x and y value. Remember, on the x-axis, the y value is 0. Which one is L again? This one is L. So this question is asking us for this point right here, where it crosses the x-axis. That's at the point 6, 0. 6 is the x value, 0 is the y value. That point is 6, 0. It crosses the x-axis right here at 6, 0. All right, nice and easy. That answers that one. Next one, where does line M cross y-axis? We worked out here. Crosses the y-axis. Line M we're talking about, this line. It crosses the y-axis right here, where the y value is -2. That point is 0, -2. Note, I put the coordinates, plural. I put the x value and the y value. 0, -2. All right? What else do they want? It tells us that the equation of line L is this. So write it first in a different form. If you transpose it and put it in a standard form, we're going to get the equation that we had. If you transpose the x, we're going to get, let's write what we would get 2y equals -x minus 6. And then to get the y alone as a subject, we could multiply by 1/2 or divide through by -1, by 2, sorry. So we could multiply by half if we want to get x alone as the subject, y alone as the subject, I mean. And so this will become y equals multiply this by a half. Now we're going to get minus a half. X multiply this by a half, we're going to get -3. Hold on there. Oh, I've transposed this 6 as well. So it's a +6, +6, +3. So you get the same equation for line L. That's what it is. Half x plus 3 minus half x plus 3. Same thing. So they gave it to us in this format though. And they're telling us that find the value of k, given that 9k is on the line. We can actually see it now, because what it is what is the value of k, what is the y value when the x equals 9 on that line. We can actually see this value on the graph as well. Let's look at it. So we look at the graph when x equals 9. We're talking about the line L, right? When x equals 9. So we're talking about this line. Now, where's x equal to 9? So 8 here, so out here, x is equal to 9. What is the y value? The y value is right here, corresponding with this. -1, -2. You're halfway between -1 and 2. That's -1.5. That is the answer. So this point here, it crosses where x equals 9 is 9, -1.5. So this is a k value, -1.5. All right, the graph is telling me that the k is -1.5 or -3/2. But then we can also get it from the equation. Everything must be consistent. We get it from the equation of the line. What we can do, we can take this 9 and substitute it for the x value inside the equation there. And then work out the y value. So if we substitute for the x and the y as well, so this equation will become, we're substituting this point in the equation, it will become 9 plus 2 times, and the y value is k. So the y plus 2k minus 6 equals 0. 9 minus 6 is 3, so we get 2k plus 3 equals 0. Transpose the 3 and divide under the 2, we'll get k equals -3/2. -3/2 is -1.5. So what they want to do by calculation, and we could also check it on the graph, the k is -1.5. So everything is consistent. Better good with that?
Yes, sir.
All right. Then now, they're asking us, find the equation of line M in this form. We know it already. Line M, we wrote it up here already. This one. The gradient is 2 and the y-axis is -3. I would tell them that. I would leave these markings on my graph and tell them that. Right? Leave these points where I wrote. Maybe come up here and write rise. On the graph, put rise. And put run. Run. And the y-axis intercept is -2. I'm going to come down here now and say to the examiner, line M. The M is equal to rise over run. I'm referring to what I did on the graph. It was rise 2, run 1, so it is 2. And the C is equal to -2. Therefore, the equation is y equals 2x plus c. 2x and the c is -2. That's it. That's what I would do. No need to calculate anything. It's all there on the graph. I would give him this, show how I get my gradient on the graph with these markings, and leaving all these markings on it. It's a part of my solution to show how I got my M right there. Right? See, I'm showing it here. Gradient is 2, and then this is my equation. That's my y-axis intercept down here, the c value. All right. And they did ask us for the C-valent part of the question as well. So, so that's it. So I can take this off because I keep skipping. Make this full screen. All right. So that's what I would do in this exam. They have to give you your marks. Do the easy way. Can't force you to do the hard way. All right. It says no. Show by calculation. See? Show by calculation that line L and line M are perpendicular. So I would say something like this. The gradient of L, and they will understand. I would say gradient. Using gradient. Using gradient. M. The gradient of line L is equal to minus half gradient of line M. Gradient of line M is equal to 2. And I would say ML times MM is minus half times 2, which is equal to -1. Once I show them that the product of the gradient is -1, it means that they are perpendicular. So I can say, therefore, L and M are perpendicular lines. That's why you show that two lines are perpendicular, by showing that when you multiply the gradients, you get -1. That's why you show that lines are perpendicular using gradient. What are we going to do that?
Yes, sir.
Next part says line L and M represent the graph of a pair of simultaneous equations. Now, simultaneous equations are used to find the points of intersection. Use simultaneous equations when you want to find the point of intersection. It represents the solution of simultaneous equations, shows where the lines meet on a graph, where they intersect. Question says, using the graph on page 11, write down the solution for the pair. The solution is just 2, 2, where they meet. 2, 2. 2, 2 is where they meet on the graph. Right here. It's clear that the two lines intersect each other at 2, 2. Hold on a second, let me deal with the dog a little bit. Right? At the point 2, 2. We're not going to solve them. You're just going to find the point of intersection on the graph. And the answer is 2, 2. Right there. I just need to write it down. See, write down. There's no need to calculate anything. Better go to that. Are you okay?
Yes, sir.
Yes, sir.
All right, good. The next question was supposed to do number 5, that is statistics. I think we're supposed to do the next question. Let me see if I can deal with the dog. Ask someone to deal with it. All right, we're going to do this next question. But let me just deal with the dog quickly. Hold on a second. All right, sorry about that, guys. All right, so we're doing this question now. It's a functions question. So in this question, we're given three functions: f, g, and h. All right. First part wants us to find g of x minus 2. It's the same process as if we were finding g of 2. We would substitute the 2 in the g function. But this time it's not 2, it's x minus 2, so no problem. We're going to substitute the x minus 2 still in the g function. All right? So let's write it. The g of x minus 2, I'm going to substitute the x minus 2 as I've said, right here. And so it's going to become x minus 2 squared minus this 5. Question says simplest form. So I want us to simplify this. I can go and expand this out and get x squared. Remember, it's twice the product of the 2. Expanding a perfect square, it is twice the product of the 2. So multiply these two things, I get negative 2x, and I double that to negative 4x. And the second term squared is a positive 4. That's what I get when I expand this bracketed term. Then I have to subtract this 5 again. So then it becomes x squared minus 4x, and then 4 minus 5 is negative 1. That is the answer for that. All right, that is g of x minus 2. The next part wants us to find f to the minus 1 of 11. So to find f to the minus 1 of 11, we're going to find f to the minus 1 of x first. Then we will go for the f to the minus 1 of 11. That's one way to do it. That's not the only way to do it, but this is the way we're going to be doing it, right? So to find f to the minus 1 of x first, right, we're going to start by saying f equals, we're going to just write the f for now. F equals 4x minus 1. Some teachers will call it y. I'm calling it f. No difference, no problem. All right, when I inverse this, the f becomes x. This x becomes f to the minus 1, which is the inverse, which is the range in the inverse function. This is the range in the inverse function, minus 1. And I want to make this a subject. I'm going to transpose the 1, make it positive, and then divide under the 4. So I'm going to get f to the minus 1 equals x plus 1. When I transpose this negative 1, it becomes a positive 1. Then I am dividing by this 4. Divided by 4. This is f to the minus 1 of x. Let's put it back of x now. So I've completed this part. And from here now, so a different color, I can do this part now, f to the minus 1 of 11. So I can say, therefore, f to the minus 1 of 11 now means that I'm putting 11 in the f function there. And so it becomes 11 plus 1 over 4. 11 plus 1 is 12. 12 over 4 is 3. So this answer is 3. That is the answer right there. F to the minus 1 of 11 is equal to 3. But okay with that? Very good?
Yes, sir.
All right.
Yes, sir.
All right, let's continue. And this one wants h of 1. They could have also written for this. H squared of 1 means the same thing as that. So instead of writing this, they could have written that. What does this mean? It means that we're going to do the h of 1 first. And then whatever result we get, we're going to substitute h again. So this becomes equal to h of 1. We're doing the h of 1 inside here first. What is h of 1? H of 1 means that we're putting 1 in the h function. What is the h again? The h was 3 to the x. Let's write it down here. The h function is 3 to the x. Let's write it here. The h of x is 3 to the x. So it means that we're putting 1 for the x there. All right? So this then becomes equal to h of 3 to the 1. 3 to the 1 is 3. So we're doing h of 3. And then h of 3 now means I want to put 3 now for the x here. Again, in the h function. And so it becomes 3 cubed. H of 3 becomes 3 cubed. 3 cubed is 27. 3 times 3 times 3. This is the answer. But I write with that. But okay?
Yes,
Yes,
sir.
Yes, sir.
All right, beautiful. All right, moving along. Then we'll come to this question. This is now a quadratics question. Let me give us this function. It's a quadratic function. And it says compute the table below and plot the graph of the function on the grid. It says use a scale of 2 centimeters to represent 1 unit on both axes. So they're telling us the scale that they want us to use. Now I can look at this and put in the values because I know that the values are symmetrical. All right. So once these values, the x values are in the same interval, you see they're going up by 1, by 1, by 1, by 1, by 1. It means that these values are going to be symmetrical outwards. So like for example, from 0, you go out to 4. From the same 0 here, you must go back out to 4. And from 0, you come into -2. So from this 0, you're going to come back into -2. So I know that my values to complete the table are 4 and -2 because I'm using the symmetrical nature of a quadratic function. But if you don't know that, then you have to calculate it. And notice they don't give any space to calculate it. They don't provide any space to calculate these two values. So I'm wondering if they expected to know the symmetrical nature of the function and therefore put in those values. But a lot of persons maybe would not know. And then to get this value here, what they would do is substitute -2 in the function for the x. And let's see what we would get. We'll get the same 4. Let's do it right here. So the f of -2, if we're working it right here, the f of -2, that's what this is, and we put the -2 in the function. Getting f of -2, right? It would be equal to -2 squared minus a -2 minus 2. All right. So this -2 squared, would give me a 4. Let me put it over to the side. Let's put it over here. Make that a little bit smaller as well. Right. So this -2 squared becomes a +4. Let me zoom it up. Then this -2 becomes a +2. This remains a -2. And so these two wipe out each other. And so we get the 4, the same 4 that I have here. All right. So that's how you'd have to calculate it if you did not know the symmetrical nature of the quadratic function. And then for this 0, it's kind of easy though. For the 0, okay, you're going to plug the 0 in here and there. And the result is going to be this -2 if x is 0. So this one kind of easy, right? So it should be -2. All right, so I've shown how we got the 4 right here by doing f of -2. All right, now they want us to plot the graph. So we're basically plotting the pairs, the coordinates. So the coordinates for this point is -2, 4. For this point is -1, 0. For this point is 0, -1 on the y-axis. -2, sorry, on the y-axis. This point is 1, -2. This point is 2, 0. It's on the x-axis. And this point is 3, 4. 3, 4. So those are the points that we're plotting. Now they told us a scale. It says scale of 2 centimeters to 1 unit, all right? 2 centimeters to 1 unit. So starting here at the origin, this is the reading to mark the scale. 2 centimeters to 1 unit. So this should be 2 centimeters to 1 unit here. So this should be 1, then 2, then 3. Notice the graph did not go past 3 in the x. Then you will go, this is 0. And you go -1 and -2. And the x value did not go beyond -2 this way, right? Then the y value is now same 2 centimeters on both axes, right? 2 centimeters again. So this will be 1 on the y-axis. This will be 2. This will be 3. That was the maximum. It went up to 4. All right. So here we're 4. And then down here now, we go to -1 and -2. And that's how we're plotting those points that are marked in blue. All right. So let's go and plot those points. Let's put it in blue. And there's something you have to be careful about. All right. So let's talk about that thing we have to be careful about. Remember the quadratic graph, this is a smile-shaped quadratic function. It has a minimum point. And the minimum point is a minimum value that occurs just once. All right. So the minimum point is going to be between here and here. Because if you notice, you have this -2 and this -2. So the minimum value is going to be a value that is below the -2 and the -2. Below the -2. And it's going to be where x is exactly, let's use a different color, let's use the purple. It's going to be where x is exactly between 0 and 1. Exactly between 0 and 1 is 0.5. Remember the graph is symmetrical. 0.5, so it's where x equals 0.5. 0.5 is where x equals 0.5. And if you want, this will be an xt value now. X value at the turning point. It's halfway between these two. Right? That's your xt value. 0.5. You can calculate it using a formula and see that it is also 0.5. Let's just do it. If you were to calculate it, remember xt is minus b over 2a for the x value at the turning point. If you look at it, the b is -1 from here, -1. So it will be minus and -1 over 2 times a. The a is 1 right here. 2 times a, 2 times 1. That becomes a half. Half is 0.5. Same value I have here for the xt value. Then to get the y value at the turning point, what we can do is plug that. We can use the formula again and say yt is 4ac minus b squared over 4a to calculate it. Or we can plug the -5 x value in the function right there and work it out. All right? Let's do it that way. So we're going to say the yt value is when the x equals the xt value in the function here. So it would be a half squared minus half minus half minus 2. What is this equal to? This is a quarter minus this half is 2 quarters, so minus 2 quarters. And this 2 is 8 over 4. I'm going to minus 8 over 4. So this becomes 1 minus 10. So it becomes -9. -9 over 4. -9 over 4 is really -2.25. So where this go down to -2, the graph is actually going down to -2.25. So the minimum point is going to be xtyt, which is 0.5 minus 2.25 right here. So the lowest point is not -2, it's actually -2.25, and it occurs where x equals half, 0.5. We have to be mindful of that. All right, enjoying the quadratic graph. Remember, it has a minimum point. You have to use your knowledge. The question is not indicating that for you, but you have to know and work it out. So these are the simple things that make the difference between a student getting full marks on a question like this. All right, so let's plot the points that we have now. So we have the -2, 4, -2, 4, -2 up 4 to here. This is that point. -2, 4 is right here. Then we have -1, 0 on the x-axis. -1, 0 is on the x-axis here, right here. Then we have 0, -2 y-axis intercept right here. Right here is your -2. And then we have 1, -2. 1, -2 is over here. 1, -2. Then we have 2, 0 right here. 2, 0 right here. And then we have 3, 4. 3, 4. And 3, 4. 3, 4 is up here. Now some persons might draw the graph and go down and then create straight across here like that because they don't know about this minimum point. And then go back up like that. It's a quadratic graph. Also, you cannot put any straight lines. So some people might be the mistake and use straight lines and try to draw straight lines like this. And draw the graph with straight lines. That will be wrong, totally wrong. It's a quadratic curve. It's a quadratic function, it's a curve. Right? And you have to recognize that there's a minimum point down here. So that minimum point is a half, -2.25. So let's estimate where 2.25 is. Now this should be negative. This is -1. This is -2. So this is -2.5 right here. Right, here's -2.5. Let's use the red ink. Right, here's -2.5. -2.5. So -2.25 is right here. So you have to put in that turning point right here. This point is the point half of 0.5, same as half, -2.25. And I'm putting these things on my exam paper and leaving it. I'm leaving this on my exam paper. All right? And make sure that I get the full marks. You have to draw a curve, a nice smooth curve, the best curve you can draw, passing through these points. Make sure that it comes down and turns at that minimum point there. And then it goes back up. And it curves like that. And you complete it like that. And you can draw it to the friend. 6, he will give you the marks. If you draw it to the friend, he will give you the marks. All right. Might not be exactly correct, but once you draw it to the points, you can set the curve it, and especially if you put it at that minimum point there. Remember, the question did not mention anything about it, but it's good to know. 6 marks for it, you know. They're gonna give some marks to persons who bring it down to that point and not just go straight across here. But that will be totally wrong. All right. So questions like these, you have to, go and work them over again. But good at that? But okay?
Yes, sir.
All right. So that finishes the question that I wanted to do on this paper. But I want us to do another, a couple of other questions based on our revision. So the revision paper that I sent you, I'm going to do a couple questions on it. All right, to complete the session. All right, so let me go and bring up that paper. All right, these are the questions I told you to do on this one. All right, there are some other questions on this paper that I want us to look at. All right, so I marked the question that I want us to do today. Right, and on Wednesday, in fact, we're having a session tomorrow. We're going to do some other questions tomorrow. So I'm inviting everybody to join tomorrow online as well. So whether you're in the Monday class or the Sunday class, you can join the session tomorrow. Same thing on Wednesday, same thing on Thursday. I sent a message in the group about that. All right, so by Thursday, we will complete all of this paper. right? And I send another paper 2 in the group for you to practice from for tomorrow's session. So we're going to use this as a good revision period. So I want us to do these 2 questions today at least to finish off the session today. And tomorrow we might do some more in this very same paper along with another past paper. Some questions on another past paper that I will send into the group. All right. So that is the plan. So let me bring up a clean sheet to write down. All right. So I want us to do these questions that I have here. All right. This first one, part A. All right. That question says, given that P is equal, not P, R. R, that's why I write R, guys. Just don't criticize my R too much. R is equal to 2P squared divided by Q minus 3. I want us to calculate the value of R when P is 6 and Q is 12. So we basically plug in these values inside the formula. Right? So the Q is going to go here and the P is going to go there, the 6. Right? That's what will happen. So the R becomes 2 times the P value is 6, so it's 6 squared, divided by the Q value is 12, so it's 12 minus 3. That's what we're working on. So this really becomes 2 times 36 divided by, this is just 9. And 9 to 36 was 4 times, and 2 times 4 is 8. So this works out to be 8. So R is equal to 8. That's the answer. What about that?
Yes, sir.
Good. Then I want us to rearrange the formula to make Q the subject. So I want to rearrange this formula to make Q the subject. What I'm going to do, I'm going to get this out of the denominator, multiply it all up as a whole, and I'm going to divide the R under here. Let me copy this down. Let me copy this. Show the movement that we're going to use. I'm going to make Q the subject now. Right. So what I'm saying is that I will take the whole of this denominator as a whole, multiply it up here. At the same time, I'm going to take this R and divide it under here. So like I'm cross multiplying and cross dividing. All right. So when I do that, I'm going to get Q minus 3 by itself equals 2P squared divided by R. But I go to that.
Yes,
But
sir.
okay with that? And then to get Q as a subject, I transpose this 3 and add it. And so the Q becomes 2P squared divided by R plus 3. Now you might ask me, why didn't I change any sign when I did these up here? Because technically, let me show you what I'm doing step by step. What I'm doing when I multiply up this Q minus 3 as a shortcut, what I'm really doing is multiplying both sides by Q minus 3. And this one cancels that one. It appears as if I multiply this up because that's the end result. But that's what happens when you practice a lot. And then now to get rid of the R from there, right? To get rid of this R, it's like I divide this side by R and also divide this side by R. And then this R cancels this R, so I left the R under here. I did it in two moves. So the shortcut, when I multiply this up here, shortcut, that is a shortcut for multiplying both sides by Q minus 3. The shortcut, because this cancels this. So the shortcut is to basically say, I multiply this up here. Because that is what we end up with. And then to divide both sides by the R. shortcut, because this one cancels this. Shortcut is to say I divide this R under there. So there's no changing of the sign when you're multiplying and dividing, and so I end up with this. You have to practice it, and then honestly transpose the 3. Now, theoretically, what does that mean? That I'm adding 3 to this side, and also adding 3 to this side. And then this minus 3 and this 3 cancel each other, and so I'm left with this positive 3. That is what does that mean theoretically. But shortcut is to say that the negative 3, bring it on this side and becomes a positive 3. That is a shortcut. We have to understand the shortcut of what. In the case, that is a result. Right? For that, for Q. Q is a subject. But okay with that? But okay?
Yes, sir.
All right. So let's do part B now, which is our factorization, right? Part B is to factorize these things. All right. So let's go. So the first thing we're factorizing is 3g minus 3t plus 2mg minus 2nt. That's 4 terms. So I know it's a factorization by parts. I will call it factorization by grouping. So what it is that you're looking for a highest common factor in the first 2 terms. In this case, it is a 3. And I realize that when I factorize them, I'm going to get g minus t in the bracket. So I want to ensure that these two also have g, possibility of a g minus t, which it does. And so the values are arranged in a friendly manner. There's no need to rearrange the values. I can proceed with factorizing by parts. So I'm factorizing these 2 first with the 3. So I get 3 bracket g minus t. I want to get g minus t in the bracket over here as well because I know I'm going to get it. All right. This is an m, not an n. This is an m. Right. So I want to get the g minus t in the bracket out here. And then I realize that when I divide this by the g, I am left with a plus 2m out here. Plus 2m. Plus 2m. So when I factorize it plus 2m out of these, I'm getting the g minus t. Then the g minus t becomes my common factor now. And so it is this 3 and the plus 2m becomes a factor to multiply the g minus t as a common factor. And so I get 3 plus 2m times g minus t. If I put the g minus t in front and write it as, I can say, or put the g minus t in front and put the 3 plus 2m second, because it doesn't matter. Same 2 factors. Same 2 factors. All right, better go with that?
Yes, sir.
But okay? All right. Then we get this quadratic to factorize now. All right, we're going to use the method of splitting the middle term. So we have 3x squared plus 2x minus 8. I'm going to use the method of splitting that 2x. All right, so to do that is the AC method. I'm going to apply the 3 times the negative 8. So it's 3 times negative 8 is negative 24. Then I want factors of negative 24 that add to the middle coefficient of a positive 2. Factors of negative 24 that add to negative 2, positive 2. All right. Now, if you can't find factors of that negative 24 that add to negative 2, you can try the list of factors. All right. I know 6 and 4. And 6 plus 24 and the difference is 2. But if you can't see it right off the bat, then you go down the list of factors. Now, since I want factors of this negative 24, I know one will be positive and the other one will be negative. Since I want the sum of the factors to be this positive value, I make the larger factor of the 24 positive and the smaller one negative. All right. So I'm going to try 1 and 24 as the first 2 factors. Make the larger one positive and the smaller one negative. But these add to 23. 24 minus 1 is 23. You don't want 23, so I exit, I want 2. The next two factors of 24 is 2 and 12. Make the larger one positive as the sum that you want and the smaller one negative. But 12 minus 2 is 10. I don't want 10, I want 2. Next two factors of 24 is 3 and 8. So I'm not skipping out anything, any of them. The larger one positive and the smaller one negative. But then 8 and minus 3 is 5. My middle term is not 5, it is 2. So I don't want that either. So I'm putting an X on the 5. Next two factors is 4 and 6. The larger one positive and the smaller one negative. Now 6 minus 4 is 2. It's a positive 2 as this is. I want to put a tick on that. Right? So it means that these are the two factors that I'm going to use. So I'm going to split this 2x using these two factors. The 6x minus 4x. 6x minus 4x is 2x. That's how we know what to split the middle term with. So this now is going to become, when I split it, it's going to become 3x squared, come back as is. Then instead of this 2x, now I'm going to write 6x minus 4x. So I'm going to write plus 6x minus 4x, because they are adding back to the 2x there anyway. And then now I'm putting back this negative 8. So I've created a situation where I'm going to factorize 4 terms. So I'm using factorization by parts now. So I'm going for the highest common factor in the first 2 terms there first. Highest common factor. That's a 3x. So I get 3x. Factorize out of that gives me x. 3x out of that gives me a positive 2. I'm going to put back the bracketed term out here. So all these negatives can mix you up. But what you have to do is you put back the bracketed term here first, which is the x plus 2. Then to know what I put inside here, which has to be plus a value or minus a value, not just a value, I can divide this negative 8 by this positive 2. Divide them to know what goes here. Negative 8 divided by 2 is negative 4. So I put in a negative 4 here. If I'm not sure, I can check it. Negative 4 times x is negative 4x, which is good. And negative 4 times positive 2 is negative 8, which is good. Then now, just as we did with the g minus t, this becomes my common factor. So it's the 3x and the negative 4 forms one factor, and the x plus 2 is the other factor. So I'm going to get 3x minus 4 times x plus 2. Those are my two factors of the 3x squared plus 2x minus 8. Right, okay with that?
Yes, sir.
Right, okay? All right. So we'll come to this third one now, which is 2 terms to factorize. I see a negative there, so I'm thinking about the difference of 2 squares right away. So I have 3x squared minus 27 to factorize. Initially, my common factor is just 3. So I'm going to factorize out the 3. Out of this, I'm left with x squared minus factor 3 out of that. Out of this 27, I'm left with 9. We must recognize 9 as a perfect square. It's a squared number. So this inside, you can be written as the difference of 2 squares. Do not throw away that first factor 3. So I'm putting back that first factor 3. And inside here, I'm writing now x squared minus 3 squared. So now that this is the difference of 2 squares, I can apply the rule. So it's 3, this first factor. And then I'm factorizing that difference of 2 squared become the difference of the numbers, the x and the 3, the difference of them, x minus 3, and the sum of them, x plus 3, x plus 3. So this is my answer, factorized completely. See the word completely? So if you stop here, you're not going to get the full marks, because this part of it can be factorized further. All right, so you have to factorize it completely. No part of this can be factorized anymore. So that is it. It has been completely factorized. But okay with that? But okay?
Yes, sir.
Yes, sir.
All right. Remember, you have to go and redo these questions for me, right? You have to go and redo them. All right. We're going to do this question now, which is a simple inequality. All right, remember, when you're solving a simple inequality like this one, it's the same steps as solving 3 minus 2x greater than equals 11, right? Same steps. You're just trying to make x the subject. The only difference is that with the inequality one, if you ever have to multiply or divide with a negative number, you have to remember to reverse this inequality sign right here. You have to remember to reverse the inequality sign when you multiply or divide the negative number, but the steps are the same as you would with a simple equation like that. All right, so let's do it over here. So we're solving 3 minus 2x greater than 11. So we're trying to make this x a subject. So I want to transpose everything away from it. I'm going to move this 3 first. So let's write what we're doing. We are subtracting 3 from both sides. When you subtract a number, you don't reverse the sign. So when I subtract 3, I will same as taking this 3 over here and changing the sign. So I'm going to benefit negative 2x. That's the key, guys. And negative 2x, not just 2x, is greater than. I subtract 3 from this. I'm going to get 8. 8. 11 minus 3 is 8. Then to leave this x as a subject, I need to divide both sides by negative 2. So now I'm dividing to a negative number. When you divide a negative number, divide an inequality by a negative number, you have to remember to reverse the inequality sign. These things have to be in your head. I'm dividing now by a negative 2. So because I'm dividing with a negative number, I have to reverse the greater than sign. And then we go. We divide this by negative 2, becomes x. This greater than sign is reversed to less than. Divide the 8 by negative 2 becomes a negative 4. So x is less than negative 4. All right. Then it also says, so this is a solution. Then it also says, determine the largest integer value of x. Determine the largest integer value of x. So if we were to list them out, right? If we were to list out the values, x less than negative 4, right? All right, let's put on a number line first so we can see it. Let's put on a number line. I think it's maybe clear on the number line. So I'm going to put the 0 here and the 1 here. The negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So I'm starting at negative 4, guys, which is right here. Putting a circle on it. There's no equal on the inequality. So I'm leaving that circle unshaded. If the equal was there, I would have to shade that circle. But there's no equal on it. So I'm leaving it unshaded. That is to say, I do not want negative 4. Negative 4 is not a valid value for x. I can be less than negative 4, just can't be negative 4. And for the less than, I am putting an arrow to the left, as I want all these values down here, which are less than negative 4. Then I can write it, x is less than negative 4. And the question says, determine the largest integer. So what it means is that you can't include negative 4. So you can take all these values starting from here, this way. Right? You can take all those values, you just cannot take negative 4. If I'm talking about the integers I'm talking about, the first integer that I can take is negative 5. That's the largest one, integer. All right? So my integers would start from negative 5. So okay, negative 5, negative 6, negative 7, negative 8, and so on. Remember, an integer is a positive or negative whole number. This is the largest one. So my largest integer x that I can take will be negative 5. So the largest integer x is negative 5. Now, if x was not an integer, guys, remember you could use a value, for example, right here, right? Which would be negative 4.5, for example, or 4.25. Let's put this in the middle. Maybe right here, which may be negative 4.5. That could work if we if it was not an integer. If it was any number, then negative 4.5 could work. But because it says a negative integer, an integer is a whole number, whether it's positive or negative. So the first whole number that I can use is negative 5. All these values are less than negative 5. Values to the left are less than values over here. Values over here are more. All right, so the 5 is more, the negative 5 is greater than the negative 7. So the negative 5 is the largest value that x can be, negative 5. All right, that is it. And also wanted us to write the solution set for this inequality, or this solution. So the solution set is basically just putting the solution in set brackets, or putting this solution in set brackets. So I'm going to write the set bracket and write x is such that, and then you put that solution, x is less than negative 4. And that is it. That's what the solution set. They did not, this part of it has nothing to do with the integer. All right. If you're saying x is an integer as well, then you have to do something like this and say, comma, x is a member of integers. Z is a symbol for integer. Z is a symbol for integer. So if x is an integer and you want to complete it, the solution set, you have to put this in it as well. But my solution did not say x is an integer, only this last part. Right? They just asked me for a value if it was an integer, but they did not originally say it's an integer. All right, but I go to that. But okay, students.
Yes, sir.
All right, good. I want to do this part of it now. It's a variations question. I see that table and it's a variations question. Let's see what it says. It says, given that y varies inversely as x, remember inversely is k divided. So that simply means that the first variable y is equal to a constant divided by the second variable x. That's an inverse variation. That's what happens when I'm an inverse variation and k is a constant. It says, use the values from x and y, use the values of x and y from the following table to calculate the A and the B. All right, so remember, they have to give you a pair of values to find the k. That pair of values is for you to use to find the k that we have in this relationship. I will always find k first. The method we are using is one where we will find k first. I've always said you don't need to find k. It can be done without finding the k, because so many of the questions will also ask you for k. We are practicing to find the k first. Whether you need to find it or not, we're going to find the k first. And what do we use to find the k? We use a known pair of values that they'll give you, which is when x equals 2, y equals 8. That's what they told us right here in the table. We're going to take these values and plug them inside this to get the k. So I'm going to say, therefore, the 8, which is a y value here, is equal to k divided by 2, which is the x value on it here. I take this 2 and multiply it up by the 8. I'm going to get that the k is equal to 8 to 16. Now that I know that the k is 16, I can take the 16 and replace the k there. And I will know my formula fully because the k is not changing. Whereas the x and y is changing, x and y are changing, the k is not changing, the k is a constant. And so the y is equal to 16 over x. This now is a formula that you know fully, connecting the x and the y. All right? But the k is a constant, I will now know it. So we're going to use that table now, use that formula to calculate the value of a right here, which is the y value when x is 32. So we're going to say, using the formula, let's use it down here. When x is 32, the y value is a. Therefore, I'm going to plug these values in that formula. So the y value is A. A equals 16 over the x value is 32. 32. 16 over 32 is a half. Right? 16 over 32 is a half. So the A equal. That's right. That don't look right. That don't look right. Don't like this value. Let me double check this. X equals 16 over x. Let me just double check this, guys. I'm not looking right from the table. Not looking right from the table. Not looking right. It's supposed to be bigger than the bigger than the thing. So this is not looking right. Let me just double check something. Let's double check. It's an inverse variation. It's an inverse variation. And so y equals k over x. And when x equals 2, y equals 8. So the 8 equals k over 2. Multiply the 2, 8 to 16, k equals 16, put that up here. So y equals 16 over x. At that point, the x is 32 and y is a. And that is it. So the a equals a half, 0.5. And on the other half of it, we're using this point now, which is when x equals b, the y equals 24. I'm going to plug these values in the formula as well. So the y is 24. So I'm going to say, therefore, 24 is equal to 16 over b. Or the x is b. I'm going to multiply the b and divide another 24. So the b is going to be 16 over 24. 16 over 24 is the b this time. So I guess the table not really in sync. So that the value is going up and down, but no matter, that's what we get. And this is, if you simplify this, we can go what? We can go 8 into this and 8 into this. So we get 2/3. That is it. That's what we're getting. Maybe this question we just made up. So the values are just randomly all over the place. So don't worry about it. But that is it. The process is correct. But okay?
Yes, sir.
All right. All right, good. All right, then we're gonna finish off with the linear programming. All right, more maths equals better maths. We're gonna finish off with the linear programming on this page. Because that's the topic that we're just on now, right? I want to solidify this topic. So we're gonna do this one right here that we can see on the screen. All right, let's go. Finish off with this question. This question says, Miss James, she buys X calculators, and she also buys Y folders. So X is the number of calculators, Y is the number of folders. Let's write that. So she's buying X calculators and Y folders. X calculators. Let's write cal for calculators, right? And Y folders. Let's write FOLD for folders. FOLD for now. So X is the number of calculators, Y is the number of folders. You don't know X and you don't know Y. All right, they're buying them to sell at a school. She buys at least 5 calculators. At least 5 calculators. Remember, the number of calculators is X, and she buys at least 5. So the number of calculators must be 5 or more. At least 5 means 5 or more. So the first inequality is that the number of calculators, which is X, must be 5 or more, meaning greater than or equal to 5. That's the first inequality. Easy like that. All right, that's the first one. Next information here is that the number of folders, which is Y, that she buys must be at least means greater than or equal to twice the number of folders, twice the number of calculators, sorry. Twice the number of calculators is 2x. That's the number of folders, Y must be at least twice the number of calculators. So that inequality is what I have on the screen there. So part 2, we're getting that Y must be greater than or equal to 2x. the number of folders must be at least means greater than or equal to twice the number of calculators. That's that. Very good with that? Very good?
Yes, sir.
Very
Yes,
okay?
sir.
All right. All right, so that's the second one. Then it says, a calculator costs $20, a folder costs $5. Miss James only has $300. She can't spend more than $300. So in terms of cost, let's write that out. In terms of cost, the calculator has $20 each, and the folders $5 each. All right. So she's buying X calculators at $20 each. So if she was buying 2 calculators, it would be 20 times 2. If she was buying 3 calculators, it would be 20 times 3. If she was buying 4 calculators, it would be 20 times 4. She's buying X calculators, so she's spending 20 times X on the calculators. Then now for the folders, it's $5 each. If she was buying 1 folder, it would be 5 times 1. If she was buying 2 folders, it would be 5 times 2. If she was buying 3 folders, it would be $5 times 3. But because she's buying Y folder, the money that she's spending on the folder is $5 times Y. So the total money she's spending is 20 times X on the calculators plus 5 times Y on the folders. And the total money that she has is $300. So she cannot spend more than $300. So this is the inequality now. The total that she spends, which is 20 times X, which is the money on the calculator, plus 5 times Y, which is money on the folder, that's the total money that she spends, must be less than or equal to the total that she has, which is 300. But okay with that? But okay?
Yes, sir.
Yes, sir.
And then this can be divided through by 4, always by 5, sorry. Always simplify down to lowest terms. We'll divide by 5. And so the 20 here divided by 5 is 4. So we're going to get 4x there. And the 5y divided by 5 is just y. And then the 30 here divided by 5 is 6. And this 0 is still there, right? So that is the equation. That's the inequality for the third condition right there. So we have 3 inequalities. 1, 2, 3 to work with. All right. Next part now says, using a scale of 2 centimeters to represent 5 calculators on the x-axis and 2 centimeters to represent 10 folders on the y-axis, draw the graph of the lines associated with the inequalities above. Then shade the region which satisfies the inequalities. All right. And then down there, they start to talk about profit. Let's deal with the graph first. All right. So before we get into dealing with the graph, we need to know what each of these mean in terms of how represented on the graph. And we don't have to write this out on the paper, but I'm going to write it for the chain of thought. All right. So for this first one, the greater than here means above. Since this x over here is positive, the greater than means above. So we're going to go above the line, above. Remember, inequality on a line is about being above the line or below the line. Because the inequality is there, we're going to draw a solid line, meaning that the lines are part of the inequality. So we're going to draw a solid line, an unbroken solid line, a solid line. And the line associated with this inequality is the line x equals 5. X equals 5 is a vertical line passing through 5. Remember, the y-axis is x equals 0. So lines that are parallel to the y-axis will be x equals a number. So x equals 5 is in that form. X equals a number as a vertical line. That's the first one. Then we have this second one here, which is y equals 2x. Again, the y over here is positive, so greater than means above. When above this line, the equal is a part of an inequality, so the line is going to be drawn solid because the line is now a part of the inequality. So we're going to be drawing a solid line. The line that we're drawing is y equals 2x. Y equals 2x is a line associated with this inequality. Then because there's no c on this line, we know it is going to pass through 0, 0. It's also going to pass through points where the y value is twice the x value. So for example, if you give an x value of 5, the y value is going to be 10. Or if you give an x value of 10, the y value is going to be 20. So you're going to pass through a point like that, right? So you're going to pass through 0, 0 and a point like 10, 20 or, 20, 40, something like that. Then for this third one, let's set it up again. All right. The y value is positive, so less than means below, going below this line. The equal again is there. The equal is a part of inequality, so we're going to draw a solid line to show that we also want the line, a solid line. And the line associated with this inequality that we have to draw is the one we're going to put here as an equal, which is now 4x plus y is equal to 60. I will need 2 points on this line quickly. Let's write it here. 4x plus 2 plus y. 4x plus y equals 60. We need 2 points on this line quickly. Set up like this. One of them I'm going to give an x value of 0. Other one I'm going to give a y value of 0. That's a quick way to do it. At the point where the x value is 0, this is eliminated. I'm left with y equals 60. That's on the y-axis. Y value is 60. And at the point where y equals 0 right here, like I've eliminated the y, so I'm left with 4y equals 60. 4x, sorry, 4x equals 60. If 4x is equal to 60, 60 divided by 4 is 15. And so the x value is 15. So you pass it through this point on the y-axis and this point on the x-axis. So that's information that we have. All right, I'm going to put the graph over here. I'm going to bring this up and put the graph down here. Let's put the graph on another page down here. Let's sketch it over here. All right, let's sketch it over here with that information. All right, let's do it over here. So I'm going to scale it up like this. Let's make the axis black. So I'm going to just put a y-axis. I'm just going to sketch it. X-axis. All right, and the scale I think was 2 centimeters to 5 on the x-axis and 2 centimeters to 10 on the y-axis, right? On the x-axis, I have to go out to 15. All right, so I'm gonna go 2 centimeters to 5. So I'm gonna go 5, 10, 15, 20. Let's go like that. So 5, 10, 15, 20. And the y-axis was 2 centimeters to 10. That's about 10, 20, 30, 40, 50, 60. It's about 10, 20, 30, 40, 50, 60. That's what the question said, right? It said 2 centimeters to 10 on the y-axis. Where is it? Where are you? You can here on the x-axis 2 centimeters to 5 calculators, which are the x values, and 2 centimeters to 10 folders. It's 2 to 10 on the y-axis, right? So now on the y-axis, every 2 centimeters is 10, while on the x-axis, every 2 centimeters is 5. All right, so this is my x-axis, and this is my y-axis up here. Let's draw the lines in blue. All right, so the first line I'm drawing is x equals 5. Vertical line through 5 right here. It's 5 right here. I'm going to draw a vertical line passing through 5. And I'm going to label the line with the equal sign. Label this line with the equal sign. X equals 5. I want above that line, above our vertical line is to the right. So I'm putting our pointer to the right. So the region that I want is somewhere here. We're not going to shade yet. The next line I draw is y equals 2x. Y equals 2x. Passing through 0, 0, passing through 10, 20, passing through 30, 60. Yeah, I don't have 30, 60, but pass through 20, 40. 20, 40, pass through here. All right, so something like that. And the pass through 5, 10 here, right here. But so it's going to pass through here, 5, 10. So let's say that is a line. All right, and label the line with equal sign y equals 2x. On graph paper, if we draw it properly, right? So it pass through maybe 20, 40. See, it will also pass through 20, 40, which is about right here. 20, 40. Right here. All right. 20, 40. Then the last line is this one down here. 4x plus y equals 60. We worked out that pass through 0, 60 on the y-axis up here. 0, 60 on the y-axis. And also pass through 15, 0 on the x-axis down here. Right here, 15, 0. So we need a straight line through those points now. So use a ruler and draw that straight line. See if you can get it straight. Like that, something like that. Gonna label the line. Oh, I didn't put the arrow pointing. Wanted what? Wanted above this line y equals 2x, right? Above this one. So wanted above this one, put the arrow pointing up. And then we want below this last one, right? Below this last one. So put the arrow pointing down, label the line with the equal sign, which is 4x plus y equals 60. So the reason I want is inside here now, bounded by the 3 lines. As we want, let's use a different color for that. Let's use the red. We want below this one, above this one, above this one. So we want this triangle here. That's the region that I want. Because since I'm gonna shade it. So do it on graph paper. I'm sure we're gonna need the vertices. Let's see. We're gonna need the vertices for sure. Because we're gonna have to work out some maximum and minimum, right? You see it there? It tells us here, right on the vertices of the shape. Let's do it from now, the vertices. Let's put them on there and write down what they are, the vertices. So this vertex, when I name it A, let's name this one B. Let's name this one C. All right, let's write what the coordinates are. Now, A is a clear 510. 510 is correct. Because on the line where x equals 5, it's also on the line where y equals 2x. So that satisfies that point. Then B, B looks like 1020. Let's confirm if it's 1020. It looks like 1020. Let's check if it's correct. Well, it's on this line. So it will satisfy that line because 2 times 10 is 20. But does it satisfy this line? Let's check it. 1020. Yes, it does, because 4 times 10 plus 20 equals 60. Good. So that point 1020 is correct for B. And then C now. C looks like 540. C looks like 540. Let's check if that is correct, because it's on this line where x equals 5. So that's the y value. Let's check if 540 works on this one. So it will be 4 times 5 plus 40. 4 times 5 is 20. 20 and 40 is 60. So good. That point is also correct, because it would satisfy that equation of that line as well. So those are my coordinates. Let me write them over here. Let me write them over here. So let me just write them for now. I think I might need something before in part C. Let's put them here first. So A is my point 510. B is my point 1020. And C is a point 540. All right, let's go back to the question now and see what they want us to do. So draw on vertices because I know I'm going to need them, right? Vertices are very important. That's where you go to work out maximum or minimum of anything. All right, so we shaded the region already. And we drew the graph, right? We drew the lines and we shaded the region. So come to this part now, down here. So it says, the profit on each calculator is $6 and on a folder is $2. Remember, there were X calculators, so multiplying this times that, and there were Y folders, so multiplying these to get the total profit. All right, so that's why the expression for the total profit. Don't know what happened to that. I want to see if I can shut them up again. Hold on a second. Let's just write this. Total profit P dollars. P is going to be 6x plus 2y. 6x plus 2y. Because it's $6 on each calculator and there were X calculators. $2 on each folder and there were Y folders. Everybody good with that? This is the profit formula. That's what they want us to do.
Yes, sir.
Right? Write an expression in terms of X and Y for the profit, right? The total profit. They don't want us to write the coordinates. So that's what we did here in part 2, the coordinates. This was part 1. This is part 2. And then they want us to calculate the maximum profit. So we need to see which point will potentially give us the maximum profit. Let's go back on the graph to see which point it would be, which of those vertices. So we know definitely it's not this one. That one is out of it. It's either here or here. You can't look and know. Right? Either here or here. This one has more Y value, greater Y value, which is $4. This one has more calculators. Well, this one has more calculators, sorry. This one has more calculators than this. All right, so you cannot look and know which one it is. So you have to test both of them. You have to test B and C. So we have a test for the profit, right? So let's put it here. I'm gonna run a little test to see which one it actually is. So I'm gonna test. It's a little smaller. It's a little smaller. So I'm gonna test for maximum profit. Test for maximum profit. I'm gonna test B first, which is 1020. The profit at B will be equal to, so you plug in these values in the profit formula for the X and the Y to see what it is if you operate at B. Point B with 10 calculators and 20 folders. So it will be 6 times 20, $6 times 6 times 10, sorry, 6 times 10 calculators, 10 calculators, 6 times 10 plus $2 times 20 folders, 20 folders. So it is 60 and 40 as 100. So the profit at B will be $100, 100. If you operate at C, which is 540, we have 5 calculators and 40 folders. The profit at C will be $6 times 5 calculators, $6 profit times 5 calculators plus $2 profit times 40 folders. This is 80 plus 30. That's 110. So therefore, it is better to operate here. You're getting a higher profit if you operate there. So when I write it there, therefore, maximum profit is, put the dollar sign in front of you now, $110. That's 30 plus 80. $110. When 5 alone, 5 calculators. That's this 5 calculators. And 40 folders. 40 folders are sold. 5 calculators, 40 folders is what you want. You want to operate at this point right here. If you want to maximize the profit right here. That's where you want to operate. All right? No, not that one. Sorry, my mistake. This one up here. C. Right? Right. 5 folders, 5 calculators, and 40 folders will maximize the profit for you. All right, guys. That's it. Body good?
Yes.
Yes, sir.
All right. So you know what to do. You know what to do. Somebody tell me what they're supposed to do. Let me hear if you know what to do.
Go home and work out all of it over.
All right. I think everybody's saying the same thing. Go home and redo all the questions that we did today. You are at home, so you have more time. There's no time to travel. So you're gonna redo all these questions for me. And the video is ready right away because I streamed it on YouTube. So when I do it on Zoom, I have to wait some time to get the video. So I'm gonna send the link to the video right away, and you can use the video to help. Remember, tomorrow everybody is invited to the class tomorrow again, whether you're in the Sunday class or the Monday class. Everybody come to the class tomorrow, right? And we'll do some more revision, more questions on this paper I sent you, and we'll do another past paper that I sent to the group. I tried to send that paper to the group today. All right, so the dog is getting antsy, so let me just end it now. So see you guys tomorrow. Okay, bye. Bye, everybody.
Yeah. Bye, sir.
Okay.
Bye, sir.
Bye-bye. All right.